All right, so let's take a look at this problem. They give us more information than what we really need. They give us the sine of angle A, the cosine of angle B, and the tangent of angle C, and that's because this is in reference to all 6 or 9 problems, whatever it is below. For this problem number 10, I really just want to work with angle A, so I really don't need these two. I can do this in multiple ways. If here with angle A, if I define angle A in a right triangle, and the opposite side, if I call it 2/3 and the hypotenuse 1, I can find this adjacent side by taking 1 squared, which is just 1 minus 2/3 squared, and I have 1 minus 4 over 9. Let's rewrite the number 1 as 9 over 9 so that we have a common denominator. And then I've got 9 minus 4 in the numerator, which is 5. And if I'm taking the square root of a fraction, I can take the square root of the numerator and denominator separately. So my numerator, I'm not going to be able to simplify that, square root of 5, but the denominator, square root of 9, I know that simplifies to 3. So that's one way that I could get this answer. An alternative way that I could get this answer, I'm just going to get this out of my way. You can copy it down if you need it if you look at the videos. If I have the sine of A and the cosine of A by the Pythagorean identity, I know that the cosine of angle A squared plus sine squared of A is equal to 1. And so I can solve this for the cosine of A by subtracting sine squared from each side and then taking the square root. Now, if I'm doing this, I probably need to make the assumption that angle A lies in quadrant 1. We'll make a more emphasis of that later on because definitely we know from algebra that when you take the square roots, you're supposed to put a plus or minus sign in front of there. But if I assume that angle A is in quadrant 1, I won't need to do that. So it tells me what the sine of angle A is up there. It tells me it's 2/3. So I've got 2/3 squared. I want you to be able to read my writing. So I know that the cosine of angle A, if I rewrite 1 as 9 over 9, and if I square this, I have 4 over 9, and you can see that we're heading towards that same answer, or at least I hope you can see it, that we've got the cosine of angle A being the square root of 9 minus 4 is 5, with a common denominator of 9, and take the square root of the numerator and denominator separately, and the square root of 9 is 3. Hey, we get the same answer that we did just a second ago with just figuring out from the definition of constructing a right triangle. And here, I figured it out using an identity. And in both situations, when I drew that triangle and assumed things, I was drawing it with the assumption that angle A was in quadrant 1. So that's what we probably should have had that in the directions to just assume the angles A, B, and C are all in quadrant 1. So hey, I hope that helps, and I'll talk to you later.